Okay, today we're going to pick up where we left off on, I don't even know, some day last week. Whatever day last week we did the product rule and the power to a power rule for exponents. Today we're going to pick up with our last three rules. We're going to do all three of them today. And then you're going to practice first with a worksheet, and then we're going to have some new teacher-assigned IXLs. But first, we need title, page number, and date in your notebook. This paper, if you haven't already gotten it, should be up in the like colored drawers at the front. I don't even know which drawer. Just look around till you find it. I think it's blue. And like I said, it looks like this with this on the other side. Okay? Once you have your paper in front of you, go ahead, continue on with the video. All right, so the first rule we're going to look at today is the quotient rule. The quotient rule is for dividing numbers with exponents. Okay? Now, just like before, just like for the product rule though, they have to have the same base for this to work. Okay, and just like we did with the product rule and the power to a power rule, we're going to look at this expanded out and talk about what the rule is and why it works, and kind of this again is sort of how it works, or I guess more why it works, and then we'll use it down here. So first thing, right, we're going to use our quotient rule. We see a division problem here because that's what it's for, is dividing. And we see same bases here, and that's exactly what we need. So first thing, let's take this and let's expand it out. 2 to the 6th means 1, 2, 3, 4, 5, 6 2's being multiplied. 2 to the 3rd means 1, 2, 3 2's being multiplied. And if you remember back to, I don't know, 3rd grade, you remember that any number divided by itself makes 1. So 2 divided by 2 makes a 1. 2 divided by 2 makes a 1. 2 divided by 2 makes a 1. And so now every 2 on the bottom has divided with a 2 on the top to become a 1. So we've got just that 1 on the bottom. And on the top, we've got 1, 2, 3 2's, or 2 to the 3rd power. Now, technically, it is still over that 1, but we know that anything over 1 is itself. And so we could write this answer one of two ways, either as 2 to the 3rd, or 2 times 2 times 2 is just 8. Okay, but for right now, I want to focus less on this and focus more on this. What happened, right? Well, we had 6 2's on top, we had 3 2's on the bottom, and 3 of the 2's on the top and 3 of the 2's on the bottom canceled out. Okay? It works the exact same way. If you've got variable bases. And so let's expand it out and let's see what's going on here. We've got 7x's, and we've got 2x's on the bottom. Okay? And even though we don't know what x is, we know that any number divided by itself makes a 1. And that'll happen again right here. Any number divided by itself makes a 1. And 1 times 1 is 1. And 1 times this stuff is just this stuff. And technically there is still a 1 on the bottom, just like there was over here. But if we want to rewrite, we have 1, 2, 3, 4, 5 x's, or x to the 5th, okay, over 1. And we know that even though we don't know what x is, we know that any number divided by 1 is just that number, okay? Pause the video for a second and think about what happened. How did we get this exponent 3? How did we get this exponent 5? All right, so hopefully you paused the video. Hopefully you thought about it for a second. And hopefully you realize, well, 6 minus 3 is 3. Hopefully you saw 7 minus 2 is 5. And that's exactly what's happening here. Okay, the quotient rule says that if you are dividing, okay, and you have exponential numbers that have the same base, okay, very, very important, same base, okay, what you'll do is keep the base just the exact same way you did it with the product rule, okay? And you'll subtract the exponents, okay? And what that looks like over here, and again, we're going to use letters to show x is just some base, M is just some exponent. We have the same base though on the bottom, x, and we have some other exponent, n. And what we do is we keep that base and we subtract those exponents, m minus n, okay? And now some weird stuff will happen as we go, and we'll deal with that in a little bit. But baseline, that's what we're doing. Keep that base, subtract those exponents, okay? So take a second, pause your video, do number 1 and 2. Stop there, though, because they get a little weird after that, so stop there. But do number 1 and 2. All right, so hopefully you've paused the video. Hopefully you've looked at number 1. I'm assuming that's an 8. I think that's supposed to be an 8. So we're going to assume that it is. We're going to keep that base. We're going to subtract those exponents. And that would be 6 to the 2nd power, right? 6 to the 10th divided by 6 to the 8th would be subtract those exponents, 6 to the 2nd. And now technically, because this is one that you really should know, 6 times 6, final answer there that most likely would be expected on a test would be 36, not 6 to the 2nd power. Okay? Same idea, number 2. Now remember first, coefficients, we just do whatever the math is with those. So this is just 4 divided by 2, which is 2. And then with our exponential part, we keep that base, and we subtract those exponents. That's, again, 8 minus 7, okay, would give us 2n to technically the 1st power, but we know that anything with an exponent 1, we don't really need that exponent 1, so it would just be 2n, okay? As you keep moving, they get a little bit weirder, but at the same time, just do what makes sense, okay? First one here, number 3, first part, you got 7 over 14. Right? That's just the fraction 7 over 14. If you need to, come out to the side. Hopefully you just know, though, that that's going to be a half, because we can do 7 divided by 7 and 14 divided by 7. And 7 over 14 is simplified to a half. Then keep your base, x and x. Okay, now y's have to be separate, but x and x, right? Okay, we've got 12 minus 4 is x to the 8th. And then over here, I think that's a 9, y to the 9th over y to the 3rd would keep that base y. And then 9 minus 3 would be a 6. So final answer there, as long as I read all the numbers right, is 1/2 times x to the 8th, y to the 6th. Okay. Now number 4, we've got some negative exponents, and there's a whole rule for that, but for right now, we're going to keep it simple. So first, we're going to do the same thing we've been doing, right? And again, if anytime you want to pause the video and try it first, and then play the video so you can check your work, that is a great idea. Or you can do them with me. Either way is fine. But first things first, 10 divided by 2 is just 5. Okay. Same base, so we'll keep that base. And please, 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 please don't get cocky. Write down these problems. These negatives are going to mess you up a lot of the time. Please write it down. Don't try to do it in your head. This is, for your exponents, it's -3. We're subtracting them, so minus. Then that one is -6. Remember last year, Mr. Gary telling you to add the opposite. And so -3 plus 6 is +3. Okay, final answer. Now, unless I can't see that right, that's a multiplication symbol, so I don't exactly know why I put it on this paper, but oh well. Let's keep on. We've got a multiplication symbol there, so we're going to use our product rule for some reason. That was probably my bad putting it on here. I don't know. Keep that base, though. Add those exponents, but those exponents are -5 plus 9 would actually be y to the 4th. Okay, I was just trying to make you review. All right, then our last one here. Again, we're dividing. We got same bases, so we'll keep that base, and we'll subtract those exponents. Remember to put them in the order they come, as in top minus bottom. Because it's negatives, I'm going to write it down because I don't want to mess up something silly. I'm going to see a negative. I'm going to see a minus. I'm going to go ahead and add the opposite. And then -5 plus -7 is -12. So the answer there is x to the -12. Now, as we go forward, you probably will This will be the last time I let you leave it as a negative because we're going to learn how to deal with that. But for right now, that's fine. We'll just leave it as x to the negative 12th. Okay? All right, take a second, pause this video, and please actually pause this video and try and think. Don't just sit here and wait for me to tell you. But pause this video and write a couple sentences, whatever you need, an example, whatever, and explain why that quotient rule works. All right, hopefully everyone paused and gave it some thought. If not, last chance, pause and give it some thought. Please don't just let me sit here and do all the thinking for you. But if you pause and you gave it some thought, why does it work? Remember, why, not how. Why does it work? Okay? Well, it goes back to this. It works because when you have a bunch of, in this case, 2's on the top, and then a bunch of 2's on the bottom, it works. We're subtracting out the 2's that canceled out, right? We're subtracting because 1, 2, 3 sets of 2 canceled out, or 3 of the 2's in the bottom canceled out 3 of the 2's in the top, and that took 3 2's out of the problem, and we are left with 2 to the third. All right, same thing here. Why did we subtract? Well, because we subtracted out the x's, up here that canceled out with the x's down here. Okay, so we had these 2 x's canceled out 2 of these x's. Once they canceled out, there was only 5 of them left. All right, so we're basically subtracting, okay, the x's down here that cancel out x's up here. All right, and so that, again, is why it works. We're subtracting off the x's, and I keep saying cancel out. The better way to say it would be that divide and become a 1. Okay, so you should have some sort of sentence, some sort of example, something down here that says that. And if not, get it there now. All right. Next rule is our 0 rule. This one's really nice because it's super easy. Okay, so we're going to talk about why it works. We're going to talk about how it works, and then, we'll be good to go. So the 0 power, or the 0 rule, is for, this is not the best way to write this, but it's the best thing I'm coming up with, for when there is an exponent 0. Okay, so right in here again, this is where we're going to talk about why it works. Okay, this right here, these 2 parts are this. Okay, so here's why it works. So we just talked about the quotient rule. Okay, so you see right here in front of you a quotient rule problem. Okay, so quotient rule here says, first we're going to expand it out, right? I've got 3 to the 4th power. 1, 2, 3, 4 3's. Same thing down here. 1, 2, 3, 4 3's. Now what happens? Well, 3 divided by 3 becomes a 1. 3 divided by 3 becomes a 1. 3 divided by 3 becomes a 1. Same thing here. 3 divided by 3 becomes a 1. So we've got all of these 3's turned into 1's. Okay? A 1 on top, 1 on bottom, and 1 divided by 1 is just 1. Well, where's the 0 here? Well, remember, if we had done the quotient rule like we just learned, right? When you're dividing, same bases, keep the base, and subtract those exponents. 4 minus 4 will be an exponent of 0, right? Well, this proves that when you have an exponent of 0, it really just equals 1. Do not get confused. An exponent of 0 is not the number itself. An exponent of 0 is not 0. An exponent of 0 is going to give us a 1. Okay? And it's because, again, this reason. Because the only way we'd get an exponent of 0 is if we subtracted a number from itself, okay? Which would be what, when we expand it out, would mean that we had the same exponent on top as we did on the bottom, and each, in this case, 3 on top canceled out with a 3 on the bottom. Okay? So let's look at it a little bit more abstract right here, all right? So I'm going to go at this one a different way, right? Let's start using the quotient rule. Quotient rule says dividing, same bases, keep your base, subtract your exponents, right? 5 minus 5 is 0. Okay, so what happens there? Or what are we going to get? Well, that'd be a to the 5th, right? It would be 1, 2, 3, 4, 5 a's. Down here would be a to the 5th, would again be 5 a's. Okay, and we know that any number divided by itself makes 1. Number divided by itself makes 1, another 1, another 1, another 1. And we got 1 times 1 times 1 times 1 times 1 is, again, we could say 1 on the top and 1 on the bottom, or just overall, it's a 1. Showing that when we have a 0 power, which we would have here really, right, because we just did that with the quotient rule, a 0 power makes the whole expression equal 1. Okay? So the 0 power, the 0 rule says, and we kind of did it a roundabout way here, but it says that for any expression okay, so for any expression, if the exponent is 0, the expression is equal to 1. Okay, and I used expression because it could be just on one thing or it could be on a whole bunch of stuff like you'll see in our example problems. Okay, but if you need more time, pause the video, write that down, and when you're ready, unpause so we can move on to 1 through 4. Okay. All right. So number 1. All right, you could do this a couple of different ways. You could see power to a power rule here. You could do a lot of things, okay? Or you could see an expression inside these parentheses, and the whole expression has an exponent of 0. That expression equals 1, period, okay? Because the whole expression has an exponent of 0 on it, and the 0 power rule says if the expression has an exponent of 0, the whole thing equals 1, okay? All right, next part, okay? If we look here now first, the 2 has to stay. There's nothing going to happen with the 2. But you see we're multiplying, and we have same bases, right? So keep that base and add those exponents. Negative 7 plus 7. Well, negative 7 plus 7 is 0. Now be careful here. There's no parentheses, okay? That 0 exponent is on the b, and on the b only. It is not on the 2. So the 2 is 2. But b to the 0 power is 1. So the entire expression, 2 times 1, final answer is 2. All right, number 3. So sometimes the 0 exponent will be for the whole thing. Sometimes the 0 exponent pops up in the middle. And sometimes it just helps you do some simplifying first thing right off the bat. So if you're looking here, I'm looking at what I've got. Now, if you can't see that, there's a negative sign on that too. I see z to the 0 power. So z to the 0 power equals 1. Okay? And 1 times y times x to the third times 9 is 9x to the third y, right? So basically, when you just have one little part that has a 0 power on it, it makes a 1, and that 1 just kind of, 1 times any number is the number. So it just kind of goes away. And now we'll do our other rules and simplify this. Well, 18 divided by 9 is 2. I've got quotient rule again on my x's here, so keep your base. Subtract your exponent, so that's negative 2 minus 3. So we're going to add the opposite, and that's x to the negative 5. And again, right here, we're going to talk about what to do with that. But for right now, we'll leave it x to the negative 5. And then we remember that the y has an exponent of 1. So we put it on there and keep your base. Quotient rule says subtract the exponents. 3 minus 1 is 2. Okay, final answer. All right. Pause the video and try number 4 on your own. And when you're ready, unpause and we can go over it. Give you a second to pause. All right. So c to the 0 power, just this the same way over here, okay? C to the 0 power is 1, right? Because it's the only thing that the 0 power is on. So c to the 0 power becomes a 1, but 1 times this stuff just stays this stuff, right? So I'm just going to kind of cross it out because it kind of just goes away. Again, I don't know if you can see that negative on that 2 there, but I'm going to go piece by piece. 24 divided by 3 is 8. Same base here, so keep that base. And subtract those exponents. That'd be -2 minus 6. Add the opposite is a to the -8. And then again, keep the base, b. Remember, there's an exponent 1 on that b on the bottom. And subtract those exponents. 5 minus 1 is 4. And your final answer is 8a to the -8th, b to the 4th. Okay. All right, again, take a second, think about this question, okay? Well, this statement, I get, whatever, okay? You're going to explain why the 0 power rule works. So come back up here and think about what happened. Why did it work? Okay, what was going on? Okay, pause the video, get some sort of explanation here. And I don't want to see it works because it's what you get when you divide, or what I want to see. Use vocabulary words, use some intelligent thought, okay? Pause the video, go ahead and explain why the 0 power rule works. All right, so hopefully you paused the video and now you've unpaused, and let's look at why does the 0 power rule work? Well, again, it just works because the way that you would have gotten a 0 exponent could be adding a negative number and its positive part, or its positive counterpart, right? And getting a 0 there. Or it could have been because you used the quotient rule on the same exponent, right? Either way, though, somehow you got an exponent of 0. Why does it work? Well, in this case, like this, it works because when I expanded out 3 to the 4th and I expanded out 3 to the 4th, it was the same number divided by itself, and any number divided by itself makes 1. Okay? Same thing here. Even though we don't know what the number a is, we had 5 a's on the top, we had 5 a's on the bottom, and a divided by a, okay, or all 5 of these a's divided by all 5 of these a's, again, made a 1. Okay? Why are we dividing? Well, because it was the quotient rule. We could have also just used the quotient rule and gotten that 0 exponent straight up, but that 0 exponent, okay, gives us a 1 overall for the expression, the value of the expression. Okay? All right, last rule. So again, if you didn't write anything here, get something intelligent down there. Okay. So our last rule is the negative exponent rule. And once we kind of talk about this, we're going to come back here to 3 and 4, and maybe even this one, number 6 on the other side. And we're going to kind of deal with that and fix those up a little bit so they're better. But the negative exponent rule is, well, 4. Well, I guess I shouldn't have said duh, but 4 for making negative exponents positive. Okay? For the most part, what you will realize is that you're not done simplifying an exponential expression until all the exponents are positive. Okay? So this negative exponent rule is going to help you take any negative exponent and make it a positive. I'm going to tell you one way, and then if Miss Collins is there today, ask her to tell you her way. It's really good. If she's not there, I'll explain it to you tomorrow, and we can kind of talk about it while we're practicing. But if she's there today, ask her to tell you about her the way she explains the negative exponent rule. All right? But in general, negative exponent rule. First thing, we're going to look at like what's going on. Okay? So the first thing we're going to do here is 8 to the 3rd divided by 8 to the 5th. You see division, you see same bases, right? We can use the quotient rule here. We can keep that base, and we could subtract those exponents. 3 minus 5 is -2. Okay? Now, we don't want negative exponents. We're not simplified until we're as simple as we can get, and all of our exponents are positive. So the negative exponent rule is going to take this, and it's going to make it positive. Okay? And the way it's going to do it is by going to fractions, okay? And we're going to pretend this is the fraction bar, okay? And we're going to make that thing a fraction by putting a 1 under it. And what's going to happen is, if we take this thing from the top of the fraction and we move it to the bottom, okay? or if it was on the bottom and we move it to the top, whatever. Okay, if we move across the fraction bar, okay, if we've taken everything off the top, that Houdini 1 that's kind of always there will still be there, so 1 on top. And I've moved this to the bottom. Crossing the fraction bar is going to make the exponent change its sign. So it was a -2. When I take it to the bottom, it'll be a +2. Okay? Why does it work? How does it work? Well, you just saw using the quotient rule, right? We subtracted the exponents. That's where we got that negative from in the first place. Okay, but why did I move it down to the bottom and make it a positive? Well, let's think about if we expanded this out. Okay, so I'm going to just kind of go like that. If I expand this out, 8 to the third, right, is 8 times 8 times 8. If I expand this out, it's 1, 2, 3, 4, 5 eighths. Okay? And the same thing we did a second ago, right? 8 divided by 8 makes 1. 8 divided by 8 makes 1. 8 divided by 8 makes 1. And I'm left with technically just my Houdini 1 on top, right? All my 8s divided out. But I still have 2 8s on the bottom. Just what we had right here, right? Technically 1 over 8 squared. Okay? So anytime you have a negative exponent, basically what happened was, if you could go backwards to the quotient rule, pretty much what happened was all of the whatever it is on top canceled out, but you had some left over on the bottom. Okay? And if that didn't make any sense, well, then just remember how the rule works. All right, but we'll look at it again here and just and see if hopefully it can make a little better sense. All right, so again, we've got variable bases. So let's take these variable bases with our exponents here, and let's use our negative exponent rule. First thing, though, like I said, we're going to simplify this with the quotient rule. We're going to keep that base, okay, because we're dividing, same bases, so keep your base, and subtract your exponents. We've got a -3. Okay. Negative exponent rule says if I make this a fraction, and I change this thing with the negative exponent, if I change its position in the fraction, so I move it to the bottom, okay, I'll change the sign on that exponent. So if I take this, and remember your 1's always hanging around up top, right? You can always say like times 1 because 1 times anything is itself. So I always have that times 1 in my back pocket. So I've got the 1 here. I move this y to the -3rd. I move it to the bottom of the fraction. And the whole point of doing that was when I cross the fraction bar, that negative turns positive, and I have 1 over y to the +3rd. Okay? And again, it worked because if I expand this out, right? If I expand out 1, 2, 3, 4, 5 y's over 1, 2, 3, 4, 5, 6, 7, 8 y's. Okay? I got y divided by y makes 1. Y divided by y makes 1. We got another 1 there, another 1 there, another 1 there. And when I subtracted them, right, because the smaller number was on top, I got a -3. But in real life, if I cancel them out and I expand it out, okay, I would have that 1 on top. And when those 5 y's canceled with 5 of those y's, I would have those 3 y's left on the bottom. Okay? So I'm going to write this in not a very mathy way. But what we're going to write here for the negative exponent rule is, okay, the negative exponent rule says changing an expression's position in a fraction changes the sign. Probably should have wrote on the exponent. Okay? Because it works too. Like if I would move this up, it would also change the positive to a negative. So it works on, you could change positive exponents to negatives the same way. Okay? Just crossing that fraction bar changes the sign on that exponent. Okay? All right. So we're going to do a couple examples here. And then we'll go back to those ones that we already talked about. And then you can, I'll tell you some IXL lessons to use to practice. Okay, so first thing, this one is as basic as it gets. All we want to do is simplify this. Now, there's no real simplifying to do, but like I said, This will never be the final answer because it has a negative exponent. I want exponents to pretty much always be positive. So I'll take 6 to the negative 7th. I'm going to make it a fraction because it wasn't 1. And I know the whole thing I have to do here is change its position in the fraction. So I need to have a fraction. So I make 1. Okay. And I'm going to take this from the top of the fraction to the bottom. Now, again, remember, there's always that phantom times 1 hanging around because 1 times 6 to the negative 7th is just 6 to the negative 7th. So we can always add that in there when we need it. And we do that basically just so you remember. When I move this part, the 6 to the negative 7th to the bottom, that 1 is still on top. But 6 to the negative 7th comes to the bottom of the fraction. But going, like crossing over the fraction bar, going from the top to the bottom, changes the sign and it becomes 6 to the positive 7th. All right. Now the negative exponent rule freaks people out. So if you can avoid it, avoid it. Like don't ever start simplifying using the negative exponent rule. Because if you do right here, you're going to make your life a lot more difficult. Because if you look at this, you see multiplication, same bases. Keep the base, add the exponents. Negative 5 plus 9 is 4, and you didn't actually have to do anything there with the negative exponent rule. Okay? Leave the negative exponent rule for last almost all the time. Because a lot of times the negative exponents will be there, but doing some other rule will kind of get rid of them before you even have to deal with it. Okay? So let's look here, right? You see division in same bases. That's quotient rule. We're going to keep that base, and we're going to subtract those exponents. All right, I got to add the opposite. And negative 5 plus negative 7 is negative 12. So I can't leave my final answer like that, right? My final answer can't have negative exponents, but right now I have one. In this case, it's not so nice. It's not as nice as number 2. Number 2, the negative kind of just went away. This time we have to deal with it. But again, if I want to take a negative exponent and make it positive, I'm going to make a fraction. And I'm going to move the thing with the negative exponent to the other side of the fraction bar. So I've got x to the negative 12th on top. I'm going to move it to the bottom. The 1 will be on top, and x to the negative 12th will come to the bottom, but the whole act of going to the bottom changes it to a positive. Okay. Number 4 has a negative on that 10. I'm sorry if you can't see it very well. But this is the first one that we have a negative on the bottom already. Well, again, change side of the fraction bar. X to the negative 10th is on the bottom, so move it to the top. Okay? When you do that, remember you always have that times 1, so you have x to the 10th we move to the top of the fraction. Crossing the fraction bar, change the negative to a positive 10. The 1's left over on the bottom, but you know any number divided by 1 is itself, so it's just x to the 10th. Final answer. Okay? All right. At any point, if you want to pause and try them yourself, you're more than welcome to. But let's look at number 5. I see division, same bases, so I know I'm going to be doing some quotient rule. I see a bunch of negatives. First thing, though, is 10 divided by 2 is 5. Okay. Then I'll do the quotient rule, keep the base. I'm going to subtract the exponents. It's negative 3 minus negative 6. I'm going to add the opposite. Negative 3 plus 6 is going to be positive 3, and I didn't even have to deal with a negative exponent there. Okay. All right. Last one. We've got power to a power, and then probably quotient rule, and then maybe negative exponent. I don't know. Let's see. So this is the first time today we've done power to a power. So if you've forgotten, remember, an exponent raised to an exponent, you just multiply those exponents. So it'll be x, and then 5 times negative 3 is negative 15 over x to the negative 16th. All right. Now I see division, same base. I'm going to keep the base, and I'm going to subtract the exponents. I'm going to write it out to the side, though, because I don't want to make silly mistakes doing easy work. So negative 15 minus negative 16, add the opposite, is just negative 15 plus 16, which is 1. So it was just x to the 1, which is just x. Okay. All right, now I don't have the explain why it works here because this one's a little bit more abstract and a little bit tougher to understand sometimes. So I didn't do that, but I could have, probably should have, but hey, just whatever for now. What I want you to do is I want you to go back to 3 and 4 here on the 0 rule, and 6 here. And I want you to pause the video. I want you to turn these negative exponents on those 3 to positive exponents. Okay? Pause the video and play it when you're ready to see it worked out for you. All right. So I'm assuming that you've paused. I'm assuming that you've tried it. Now let's take a look. So we're on the 0 rule 1 here. We're on number 3. So remember, I only want to move negative exponents. Okay? That's got a positive exponent. That's got a positive exponent. Only the x needs to be fixed. So I'm going to go ahead. I'm going to rewrite it for a second here just to separate it out. Okay? So I know that this is based on changing sides of the fraction. So I'm going to make a fraction. And this guy needs to have a positive exponent. So I'm going to move them to the bottom of the fraction. The already positive exponents, they stay put. So 2 and y squared, they stay on the top of the fraction where they were. The only thing that moved was x to the negative 5th. It comes down, and because it changed side of the fraction bar, it's now changing its sign. So negative 5 became positive 5. Okay. If you think you messed up number 4, pause and try to fix it before I go over it. You'll have a second while I rewrite it here. All right. So this is number 4. We want this to have all positive exponents. So again, I know anything with a positive exponent already is going to stay put. I know that a to the negative 8th is the only thing that does not have a positive exponent. I know that this is all based on fractions, so I'm going to make it a fraction by putting a 1 under it. And the only thing that's changing sides is this thing with the negative exponent, a to the negative 8th. So 8 stayed put, b to the 4th stayed put, but a to the negative 8th came to the bottom. And again, the entire purpose of moving it was to change this sign so that negative 8 would be positive 8. Okay? And actually, I don't think we really need to do this one because you kind of just did it right here, wherever that went, number 3 here. But I just realized that a second ago, so if you already did it, let's take a look. We got x to the negative 12th. Make it a fraction. Change its side of the fraction. Going from the top to the bottom. That 1 gets left behind, stays put. X to the 12th comes to the bottom. Changing from top to bottom changes from negative to positive. And that is number 6 as simplified version of all positive exponents. Okay? All right. Now, from here, there should be a worksheet that looks like this in the wherever you found this paper. Okay, so everyone get that and try it. If Miss Collins is there, you guys can go over it together. If she's not there, then we'll go over it tomorrow when I get back. Otherwise, or if you finish that or when you finish that, your new teacher-assigned IXLs, you might have already seen them, and some of you got a head start on Friday, are R4 and R6. That's the product rule and the power to a power. And the new ones that I'm adding now that you've done these rules are R5, which is the quotient and the negative exponent rule. And then R9, which is just kind of everything mixed. All right, so these will be due. I think these I've got 3, 7. So these will probably be somewhere around there too. I might adjust that later, but for right now, that'll be what it is. Okay, so if there's time, go ahead and do those. And make sure that you glue this paper onto page 53. All right, have a good rest of your day, guys.